Hello and welcome to your States of Motion video notes. Today I just want to talk a little bit about some of the terms that I'm going to want you to know for this unit, and once you know them I'm going to want you to use them on a regular basis. So let's start with our first term, which is mass. This is something you probably already know, but mass is just how much matter an object has. Please do not confuse mass and weight. We will differentiate between those two a little bit later on, but they are not the same. Mass and weight are not the same. Mass is measured in grams. All right, so a quantity, you probably use quantity all the time, and this is one of the things that I want to do with these little terminology, vocabulary video notes, is to make sure that you understand how we're using these terms in physics. Sometimes they're used slightly differently than they are in your daily life. So a quantity in your daily life and in our lives is an amount of something, but when I talk about it like, oh, you know, the quantities balance, right? I'm talking about a measurable characteristic like mass. Magnitude is the size of the quantity, right? So I could have 5 grams or I could have 100 grams. That's the magnitude. You also have orders of magnitude, and that's how much larger something else is, just as a side note. So when you talk about powers of 10, like 10 is a magnitude of 10 larger than 1, 1,000 is a magnitude of 10 larger than 100, so we'll also see it there. But when I say, oh, that's the magnitude, I'm really talking about like the value, the size of the value. So constant means the same thing. It means that there's no change in the quantity, no change in the motion, right, whatever's happening. When something is directly proportional, that means that it increases with something else, so the quantities are changing in the same direction. So if I push harder on something, it will go faster, the force goes up, the velocity goes up. Okay, so there's an example there. Inversely proportional is the opposite. When one thing goes up, the other thing goes down. And we will talk about these more as we get into more relationships and when we start graphing. Yay. All right, at rest, not motion. Motion is a change in position. So if something is moving, it's changing its position. Speed is how fast something is changing its position, and it is a scalar quantity. That means that it is a quantity with a magnitude only, right? So 5 kilometers per hour. That is the number, but you don't know where it's going, and that's the difference between speed and velocity. A velocity is a speed in a particular direction, and this is a vector. So scalar quantities are just the magnitude. Vector quantities are a magnitude and direction, and we'll be using those as we go throughout the course. Speed is a scalar, velocity is a vector. You could probably imagine a cute little mnemonic device to remember that if you wanted to. Inertia is the tendency of an object to resist changes in its motion. So think about how hard it is to get something started moving, right? That's because you have to overcome the inertia there. And the same thing to slow something down, and we'll talk about this more as we explore more about kinematics and dynamics, so the movement of things and the forces acting on those things. And then a force is just a push or a pull. Now we'll have some other additions to that definition a little bit later on, but right now it's just a force, or it's just a push or a pull. Net means that you're adding everything together, okay? So if you've got a bunch of forces acting on an object, you're going to add them all together to get a net force. And it's very much like a, say, net paycheck, right? You get paid a certain amount, and then they take out a bunch of stuff for benefits and taxes, and then you're left over. So you had your gross paycheck, and then you have your net paycheck when you're done, which is not the same. And so that's how that works. And we'll be talking about this when we are talking about equilibrium and balanced and unbalanced forces. So when you have unbalanced situation, all of the quantities do not add up to 0. Okay, so if something is unbalanced, it means that when you add everything, so if I push on this side, here's this better. If I push on this side of something and I push on this side, right, I could still get it to move if one of those forces was bigger than the other one. That would be unbalanced. But I could also push on both sides. Think tug of war. Let's do a pull instead. Tug of war, one side and the other side, if they're pulling equally, nobody moves. They're pulling, but nobody moves. And that's a balanced set of forces, okay? But if one side pulls harder than the other, that's unbalanced. Now, when all of the actions are balanced, then we're said to be in equilibrium. Now, equilibrium doesn't mean static or unchanging, because think about if you fill up a water bottle, right, and you poke a hole in the bottom, what's going to happen? All the water is going to pour out, and the water level starts to drop, right? This would be unbalanced. But if you put that water bottle under the faucet and you put the water in at the same rate that it's pouring out, you can get that water level to stay right where it is. That is an example of equilibrium. In this case, it's dynamic equilibrium because you've got a change in terms of the water that's flowing through, but that water level is in balance. It's in equilibrium. Okay, so those are our terms that we're going to be using. So now that you've watched the video, you can go and take the little mini quiz, and every mini quiz will have a secret word in it somewhere throughout the video. Right now it's at the end because this is our kind of introduction to that. But every video will have a secret word, and today's secret word is Newton, right? N-E-W-T-O-N. Newton is your secret word. So go take your mini quiz and ask me questions when I see you again in class, and thanks for listening.